Hi, welcome to this lab. In this lab we are going to learn how to configure the EIGRP dynamic routing protocol on the IPv6 network topology that we have configured in previous lessons. As you know from previous lecture, the EIGRP is an enhancement of Cisco Interior Gateway Routing Protocol IGRP, and both of these protocols are Cisco proprietary protocols, and they are only operate on Cisco routers. Okay. Now we want to configure the EIGRP protocol in router 1, R1, router 2, and router 3, R3, and also in ISP router. And we will set a default route from router 3 to ISP, as we did in the RIP-NG lab, in the previous lab. Okay, let us start. We will start with R1 router, so configure terminal. Okay, the configuration of EIGRP begins with this command: IPv6 router EIGRP 100. This command is issued or is executed in the global configuration mode to create an EIGRP for IPv6 routing process using the as number, which is 100. This command actually is similar to the EIGRP as number command used in IPv4, but in IPv6 the as number, which is here 100, must be the same in all routers in the domain. So this is the main difference between the EIGRP for IPv4 and EIGRP for IPv6. Okay, let us continue the configuration. Now router ID 10.1.1.1. Actually, this is to configure the EIGRP router ID. The ID should be 32-bit, just like IPv4 address, which is represented in dotted decimal notation. Now we have to execute no shutdown command. No shutdown is required to activate the EIGRP for IPv6 routing process because by default this process is shut down. So we have to execute no shutdown command. Okay, end. That's all for the, let's say, for the first phase of the configuration. Now we have to identify the router number, which is 100 in our example, in all interfaces. So again, configure terminal, then for the first interface, which is, let us see here, which is fast Ethernet 00. Okay, the IPv6 EIGRP 100. This is to identify the EIGRP router in the interface. Okay, for the next interface I will do the same, which is S00. Okay, the same. And the third interface, which is S0/1, same command. Okay, and for the loopback 0, the same command. End. That's all for the first router. So you can say that we did it in two phases. The first phase is to identify, to enable the process, the EIGRP process in the router, and to identify the router ID. Then we go to interfaces one by one and identify the router or the process ID number, which is 100. Okay. Now we want to just to verify the configuration. Remember, we did it only in router R1, so we cannot, verify our configuration for the whole for the whole domain, for the whole topology. So we will execute a command just to verify the configuration in the first router EIGRP, which is show IPv6 EIGRP neighbors. This command EIGRP. Okay, this command will return, for example, a notification method to indicate whether the configuration has been done successfully or not. In our case, we have no problem. This command returns this message, so we have no problem. Okay. In some cases, for example, we did not execute this command, which is no shutdown. The show IPv6 EIGRP will return EIGRP is in shutdown. So this message will indicate that you did not execute no shutdown command. And if you configure the EIGRP process and the router ID cannot be automatically configured because there is not an active IPv4 actually like address, this command will inform you of the issue with the message exactly no router ID for EIGRP 100. So this command is important to show the configuration in a specific router. Remember, it is show IPv6 EIGRP neighbors. Okay, now let us do the configuration in R1. Just to speed up the configuration process, I will copy and paste the configuration commands. It's the same, but we use another router ID, which is 10.1.2.2.2. We use the in router 1, if you remember, 10.1.1.1, but here in router 2 R2 actually we use this ID, which is different ID, but the EIGRP process ID number is the same, which is 100. So copy and paste in R2. That's all for R2. Let us do it in R3. Here we use another router ID number, which is 10.3.3.3. So copy and paste it in R3. Okay, this is good. Now we did the configuration in R1, R2 and R3. Now the next important step is to configure a static route on R3 here and ISP, which is will be actually default route. Okay, let us do it. The process is the same as we did in RIP-NG. So we will go first in R3, configure terminal. Okay, IPv6 route. This is a static route. ::/0 through the S1/0. Okay, end. Good. This is just to define a default route through the ISP router. Remember, here will be a default route through the S01 to the ISP router. Okay. Now we want to configure also R3 to propagate, to distribute this default route to other EIGRP routers, adjacent routers, R1 and R2. Let us do it now. Configure terminal interface S00. Okay, IPv6 summary dash address EIGRP 100::/0. Okay, then the next interface is S01 and the same command. Okay, this command will distribute the default route actually to router R1, and the next command, this command, okay, this interface and this command will distribute the default route to R2. Okay, end. Now we configure the default route in serial 10 in router 3, and we allow this router to distribute the default route to the adjacent routers. Okay, now we will go to ISP, and we need to configure this router with a static route to reach the domain, this domain. Okay, because we don't need to configure dynamic route, we need only to configure, because it is point-to-point connection from R3 or between R3 and ISP, so we need to configure a static route. Okay, configure terminal. Good. IPv6 route 2001 colon db8 colon 2001 colon slash 48 through serial 00. This is the global prefix for the domain, as you remember, which is 2001 db8 2001 colon slash 48. Sorry. Okay, good. Then end. Okay, now we want to verify the process of EIGRP for IPv6 that we have configured in our topology. Let us start with this command, show IPv6 protocol. We will execute this command in R3 router. Okay, this command is displaying here the parameters and the current state of all active IPv6 protocol processes, including the EIGRP process. Here, the highlighted row here in this list of the command, we can see the default route, which is colon slash 0, that was distributed to R1 and R2 through serial S00 and S01. Okay, another command that we can use is show IPv6 interface fast 00. This command verifies that the R3's fast Ethernet 00 interface is now a member of EIGRP for IPv6 multicast group, which is FF02::A. This multicast group is used by the EIGRP for IPv6 to update EIGRP messages or states. Let us say like that. Use this to broadcast messages for updating the state of the topology. Okay, we will go now to R1 and issue this command, show IPv6 route EIGRP. This command displays the EIGRP for IPv6 routes in R1s. Here in R1 actually routing table, including the default route. This is the default route that has been received from R3. Okay, the administrative distance also is shown here, which is 90 for internal EIGRP route. Actually, this is same as for IPv4. Okay. Now we will issue the same command. You remember this command? We execute it after configuring R1. Show IPv6 EIGRP neighbors. Okay. Here we can see we have two neighbors, and they are listed with the link local address. This is FF 80::2. This is the address for router 2, R2, and this is the link local address for R3, router 3. Okay, that is good. Everything seems, perfectly. Now in R3 we are going to execute this command, show IPv6 EIGRP topology. Sorry, topology. Yes. This command displays the topology table of EIGRP for IPv6. All of R3's routes are in the passive state, as you can see here. P state. P means passive. P. So all routes are passive. Okay. Now let us do the our friend command, which is ping. We will ping from R1 some addresses in the domain. Okay. From R1 here we will ping, for example, this interface. So ping 2001 db8:2001. Sorry, not 2001. This interface, which is FE00:1::. Here we have 2. Okay, the success rate is 100%. Very good. Now let us ping this interface. Okay, ping 2001:db8:2001:A3. Yes, A3::1. Very good. Success rate is 100%. Okay. Now the last command that we want to explain here is how to remove the EIGRP for IPv6 from router. You need only to execute this command, configure terminal. Then you need to execute no IPv6 router EIGRP 100. So executing this command in the global configuration will remove the EIGRP for IPv6, including any interface configuration commands used by that process. So you will remove totally the EIGRP process from the router. I will not execute this command. I will just delete it because I don't want to remove the configuration.
Okay, that's all for this lab. Thank you very much and see you in next lab.